a brief summary of what we did here. There's misconceptions all over the place about some very basic rules of algebra that you should learn in pre-algebra, as a matter of fact. Okay, first, a times b is equal to the square root of a times the square root of b. It's easily proven that this is the case. If we multiply a times b times a times b, if we multiply the square root of a times b times the square root of a times b, we get a times b, because what's a square root? It's what we multiply by itself to get the thing we're taking the square root of. So, this has to be so. Now, let's just multiply square root of a times square root of b by itself. Here we have it. Okay, and this equals what? Well, we have four numbers to multiply. We can multiply those four numbers in any order. I choose to multiply them in this order. I choose to rearrange them so the a's are together and the b's are together. And if I do that, well, the square root of a times the square root of a is a, so I could actually group that maybe. And the square root of b times the square root of b is b. I don't have to be grouped, but maybe it clarifies it, maybe not. In any case, this gives us a, this gives us b. Same thing, this squaring the square root of a times b gives us, so that this and this, either way, will be the square root of ab. So you have sort of a distributive law of square rooting over multiplication. Okay? Now, square root of a plus b is not equal to the square root of a plus the square root of b. It's very easy to prove. First of all, if you square the square root of a plus b, you get a plus b. If you square square root of a plus the square root of b, you don't get a plus b because of the distributive law. Square root of a times the square root of, well, square root of a times, well, just applying the distributive law. Square root of a times all this is, well, there it is, plus the square root of b times all this. We have this, and that distributes again to give us this expression. Square root of a times the square root of a is just a, square root of b times the square root of b is just b, but you have the square root of a times the square root of b plus the square root of b times the square root of a. We reverse those two terms and add them together. We find that when we square this side here, we get a plus the square root of 2ab plus b, and that's not equal to a plus b unless it happens that either a or b is 0. Okay? And related, very similar to what we just did here. Another common thing that I see all the time is people will square a plus b, or square some quantity where you have something plus something else, and just get this something squared plus that something squared. And it comes down to the fallacy that a plus b quantity squared is a squared plus b squared. Easily disproven. This is not equal to this because if you square a plus b, you get a squared plus 2ab plus b squared, just applying the distributive law. And that is not equal to a squared plus b squared unless a or b happens to be 0, which would make the 2ab 0. So we want to kill that fallacy immediately, and we really want people to be alert to this so we don't see that mistake